Welcome back. We're going to talk real quickly about reading spark plugs. That was something that I wanted to do in previous videos and in our class sessions. We didn't make it to that, so we're going to do that now. I've loaded up the document camera, and we have a series of spark plugs and a description of air-fuel mixtures. And one thing I will say about the spark plug is it's a good window inside the combustion chamber. So by looking at your spark plugs and reading them, it's going to allow you to determine, is the engine running rich? Is it running lean? Maybe is it running too hot? Is it burning oil? Does it have a compression problem? Because this spark plug goes right inside the combustion chamber like so, and gives us a great indication of what's going on inside the engine. So we're going to look at some different spark plugs. Now, they do make spark plug tools to do that, which basically consist of a magnifying glass with a light. But we're going to use our document camera here to kind of do the same thing. I have the light turned on for our document camera, and we have the ability to zoom in on the spark plugs. So we should get a pretty good view of these various spark plugs and get a good indication of how to read them. The first spark plug that I have set on my drawn engine here is a brand new spark plug there. And of course, I've drawn an engine kind of symmetrical. It's a hemispherical combustion chamber, so that spark plug's right in the center. But no matter what the shape of the combustion chamber is, whether it's a wedge design or a flat head, or the spark plug is still going to give you a good window as to what's happening inside that combustion chamber. So with that, let's zoom in and look at these various plugs. One thing that I will say is that we need to do a quick review of rich versus lean. Remember, rich is giving you more fuel to your engine. So you have more fuel in proportion with the air. Lean is less fuel in proportion with the air. And if I remove my spark plug, you can see that the stoichiometric mixture in an engine is 14.7 to 1 if it's running gasoline. Now, what does stoichiometric mean? It means it's in balance. And I look at this mixture to be the all-around best compromise between good fuel economy, good performance, and ultimately low vehicle emissions. So your fuel-injected car engine, for the most part, it's going to want to run a stoichiometric air-fuel ratio. However, a small engine that's air-cooled, it's usually going to want to run a little bit on the richer side of things so that we have extra fuel entering the combustion chamber in the intake stroke, and that fuel can be used to cool the combustion process and keep the engine temperatures within check. You know, when we look at performance, we largely say that our air-fuel ratio is a factor of thermal management, and we use air-fuel ratios oftentimes to keep our engine temperatures and combustion chambers temperatures within control. If we lean out the mixture too much, we go 15.5, 16 to 1. If we go too lean, our engine can run too hot, and we can actually melt a hole right down through the piston. Likewise, if we go too rich, let's say 9 to 1, 10 to 1, now we're likely to carbon up the engine excessively, maybe foul out the spark plug, and make the engine run poorly, or maybe not run at all. Obviously, that would cause emissions to go up as well. Of the two conditions, running rich is safer than running lean. I mean, we do end up diluting the oil with fuel because fuel gets past the piston rings down in the combustion chamber, or past the piston rings down in the crankcase, dilutes the oil. But still, of the two, if I run lean, I'm melting holes in pistons, potentially. If I run too rich, I'm usually just carboning things up. So it's always safer to run richer than lean. And of course, our ideal air fuel mixture for gasoline is going to be about 14.7 to 1. And then our tuning is going to be from there based on what are we trying to do with this engine. Well, our spark plugs are a great window into that tuning. So let's take a closer look at these plugs. Okay, so what I've made here is a spark plug stand to help us view the spark plugs a little bit more clearly. We're going to start off with a brand new spark plug. So if I zoom in on this plug, you can see the center electrode and the ground electrode pretty darn clearly. I'll refocus my camera and give you an even better shot of that. So you can see that center electrode porcelain is nice and white. The ground electrode has nice sharp edges because it has not been ran in the engine. This particular spark plug, like most of the ones that I have here, uses a gasket to seal the bottom. Remember, spark plugs can have two different bases. They can seal with a gasket like this, or they can seal with a tapered seat. I find the gaskets are very common in small engines, where tapered seats are more common in passenger cars. So there's a brand new spark plug. If I look at my next plug that's ran in an engine, what you'll notice with it is that, one, it's got a very small electrode. It's a different center electrode design, but it's ran in the engine, and you can see just the slightest amount of discoloration on the center electrode. It's a very, very, very light tan, okay? That would be a example of a spark plug that's running just about that stoichiometric mixture. So it's got a little bit of color to it. It's fairly light. It's right at that ideal air fuel mixture. This case, I would put it somewhere right around 14 and a half to 1 air fuel mixture. It's right there. If this spark plug was running leaner, it would be wider. So if your center electrode porcelain looks as white as the brand new plug, but it's not a brand new plug, that's an indication that your engine is likely running too lean, especially if this engine is like on a small engine, outdoor power equipment, or a motorcycle, or something of that nature. That's going to be too lean of an air fuel mixture. In fact, I would feel like this spark plug here is borderline too lean for outdoor power equipment, knowing that a lot of that stuff is air cooled, and it's going to be set up to run a little bit on the richer side of things. So now we need to move to our third spark plug. And for that, I'm going to move our inspection box, and we'll view this one, and you can see that it's got a little bit more color on its center electrode, right? A little bit of deposits and stuff, but not, it's still relatively clean. This gasket was removed on this one because we are running a temperature sensor underneath the plug on this engine. But yeah, this engine's probably running right around 13 and a half to maybe 14 to 1. So it's slightly richer, and you can see more color. Ideally for, again, an engine maybe on your motorcycle, outdoor equipment, we want to run a little bit richer, and we want to see a little bit of tan color there. A little bit of a light coffee color is what we're looking for. As we get richer, you'll see the center electrode gets darker. Okay, we've reset our spark plugs in our view box here, and we're going to progressively get richer again as we move down the row. So if I look at this spark plug right here, you can see that again the center electrode has more color to it. It's got more of that coffee or caramel color. This one's ran in the engine a little longer. It's starting to build up some ash on there. This was a 2-stroke engine, so a little bit of that is to be expected. And that's still pretty darn close to what you want as far as an air-fuel mixture, especially on a 2-stroke. You don't want to run it too lean because remember, your fuel also provides your lubrication on a 2-stroke engine. If we again move down and look at our next plug, you can see we're progressively getting richer and richer. And this one's, you know, borderline. We have carbon starting to come about, and this plug's not fouled out yet, but it's definitely richer. It's been in there longer. It's got more deposits that have stuck to the insulator, and we're moving richer and richer. For our last plug, this is a plug here that this is an excessive rich run, and when I get really rich like this, you can see how dark the center electrode is, but also you have to suspect, you know, do I have a compression problem? Am I getting oil past the piston rings and that oil is sticking to the center electrode? If this was wet looking, it would be more of an indication of a compression issue. It's not that wet. It's a little bit dirty from being in the shop here, but I would say this engine's just running rich. But whenever I have a dark colored spark plug, I want to check the engine's compression just to verify that I don't have a compression issue and that I'm mostly related to air-fuel mixture as far as that darker plug color. So there's several different indications you can get from looking at the spark plug. I've shown you a good view of how the air-fuel mixture impacts the spark plugs. But we'll look at a few images here shortly of different spark plug failures and what they'll look like in the engine from my classic Champion spark plugs poster. So Champion and various spark plug manufacturers over the years have made some great documentation of reading spark plugs. And they say, use spark plugs, tell a story. And they certainly do that. So let's look at some of these spark plugs. Here we have our normal spark plug. Like we've talked about, a little bit of a tan color. It's the correct heat range. You'll notice that maybe there's some slight wearing here on the ground electrode and the center electrode. But that's what your plug should look like for all intents and purposes as you pull it out of the engine, right? If we go to our worn spark plug, you can see that the center electrode and the ground electrode has worn down quite a bit. We're starting to get a little bit of ash deposits, but nothing really concerning. That would be very common for a high mileage spark plug that is not coated with platinum or any wear resistant elements. So if you have a standard copper core spark plug with a lot of miles on it, this is how it's going to look. Okay, this one we've talked about quite a bit. Carbon deposits. They say rich mixture or weak ignition. It could be weak ignition, but it's usually related to too rich of a mixture. Now, if we contrast this to our next one, we'll see a slight difference between the two. Oil deposits, poor oil control. This is, you know, oil getting in past the piston rings. So like I said, do a compression check. It could be also past the valve guides, which you would not pick up on a compression check. But if you put a vacuum gauge on an engine, you should be able to diagnose that. But if you put a vacuum gauge, you should be able to diagnose that issue. So the difference between this and the rich mixture is the rich, you notice that this center electrode was a little bit drier looking. If it looks a little bit shinier, that's your oil, and that's going to also foul out the spark plug and prevent it from providing spark correctly. Could cause a misfire, but it's going to give you that little bit of a shine to it. Other things you're likely to see, ash deposits. If you have a little bit of oil burn, maybe some fuel additives, and a high mileage, that stuff tends to cling, especially to this ground electrode over time and build up. It's not excessively concerning unless this happens in a pretty short period of time. So you get some ash deposits. I'm not that worried about that. If you're getting it very quickly, then that tells you that you likely have some oil contamination or some weird stuff going on in your fuel leading to those ash deposits. If these ash deposits bridge that gap, remember that's going to kill spark to that cylinder and cause a misfire. Pre-ignition. If you find that the ground electrode or center electrode is melted away in your engine, that's going to lead you to say, okay, I have some knocking, pinging, detonation. And if it's real extreme, like they're melted apart here, pre-ignition. So center electrode generally melts first, the ground electrode follows. This oftentimes is bright white from a lean mixture. You run it too lean and these start to melt away. However, it could be dirty like this one right here is because of debris flying around in the engine getting stuck to that hot center electrode. Now, one step less than this would be detonation. So when I look at my detonation in the spark plug, you can see it's not melted away as dramatically as pre-ignition, but we're starting to have some misfiring. This again could be due to low octane fuel. It could be, as it says here, maybe improper gap setting, but also a spark plug that maybe is too hot in heat range or a lean air-fuel mixture. I said if the mixture was too lean, the insulator is likely very white. Here we have one with a white insulator. It's obviously running too hot. It's starting to melt the ground electrode, the center electrode, and that that is definitely going to cause issues, and likely this is what you see, and you're likely to see other temperature-related issues in the engine. So like if you have an engine that overheated and blew a head gasket, you pull out the spark plugs, you're likely to see something like this inside that engine when you remove the plugs. I have a couple other plugs I'd like to look at here. This one talks about gap bridging. And what I will say is that anytime you have foreign contaminants bridge that gap between the center electrode and the ground electrode, that's going to cause a misfire, right? We're trying to get electricity to jump this gap. If we have carbon deposits, anything that gets thrown in there and bridges that gap for us, that's going to relate to a misfire, which essentially will give you a dead cylinder in the engine, and you'll have that cylinder not contributing to the engine's power output. The engine should run rough, and if you do a power balance, you could figure out that issue. Last but certainly not least is mechanical damage. If you take your spark plug out and it looks like this, there's indications that the piston has hit the spark plug. And I see this a lot after people rebuild an engine and they take it to the machine shop and they do all kinds of work on it, and maybe they milled too much material off of that head. Maybe they put the wrong set of pistons in there trying to raise the compression, and now they don't have enough clearance volume. I've also seen it where we have rod bearing failures cause this issue. So if this guy's all beat up, something has come apart mechanically, and you need to figure out what that is. So the question then becomes, when do I read my spark plugs? It depends on what circuits of the carburetor am I interested in looking at. Remember that your carburetor could have 6 different circuits in there that'll all affect the air-fuel ratio. When it comes to metering the right amount of fuel, you have your main metering system, you have your idle circuits, you have acceleration enrichment, you have power enrichment systems. But typically people are trying to figure out, well, I want my correct main jet. So I have a bunch of jets here. And if I am interested in selecting the correct main jet by reading my spark plugs, I'm going to want to be running down the track at wide open throttle shut off the engine, and then coast into the pits and do that spark plug inspection. So wide open throttle, that's how I'm going to pick my main jet. If I'm concerned at other times, like, or I'm just idling around, remember, then my spark plug color is going to be an indication of also my idle circuits and off idle. So here you can see I have different needles. I have a slide with a needle in it here. Selecting the right needle has an impact on that transitionary air-fuel mixture. And of course, these different pilot jets will affect that idle mixture as well as the idle mixture adjusting screw or pilot air screw. If I don't do this plug check after a wide open throttle run, I'm not going to get a good view of the main metering system. That spark plug color is going to be an indication of the other circuits of my carburetor. So keep that in mind. If I'm using spark plug color to pick the right jets and I'm concerned about the main metering jet, I want to do that at wide open throttle when I should be on that main jet. I do have to wrap things up by talking about other spark plug designs. So here's, again, a view of that normal conventional spark plugs, conventional center electrode, ground electrode. There's no platinum coating on these. It's just a copper core spark plug. Then you begin to see lots of plugs that feature some unique ground electrode designs. Like here's the classic split fire plug. This spark plug came about in the 1990s, I believe, and was pretty popular for a time. And it's brought about a whole host of other plug designs. Here's our E-Fire spark plug. And so let's talk about these different electrode designs. Spark likes to jump between nice sharp edges. So if you do have extra sharp edges on your ground electrode, it does give you more locations for the spark to jump between the center electrode and the ground electrode. Also, what you see today on a lot of other plug designs is coatings on the center and ground electrode. Coating things in platinum or iridium can help keep the plugs together for a longer period of time and prevent the erosion of the plug. And so a passenger car plug these days is going to typically have a double platinum type of spark plug to give you that long service life of 60,000 plus miles. So do the extra ground electrodes, do these other shapes affect combustion? Well, they likely do. It's not something that I've been able to measure on the dyno equipment that I have access to. It does give you, again, more surfaces for the spark to jump across. But what I would stress to you more than anything else would be to make sure whatever spark plug that you're going to run in your engine, that spark plug be what the manufacturer recommends and that it's the right heat range. So here we have a B9 ES. That's going to be a colder plug than, let's say this BCP 5 EV. Now the other digits relate to the electrode type and the threads and all that stuff, but that numerical digit, that 5 versus the 9, represents the heat range. And that's important. A spark plug that's too hot is going to keep too much heat in the combustion chamber and can even burn a hole in the piston. One that is too cold is going to be more prone to fouling out. So make sure that you're using the factory recommended heat range for your engine and read those plugs, and it'll tell you a lot about the condition of that engine. Well, that wraps up our conversation on spark plugs. I hope you've enjoyed this session, learned a little bit. Now get out there and read those plugs.